Hey guys, welcome to my YouTube channel. So myself Rohit, I am an enterprise wireless engineer. So I have already cleared gate twice and also other competitive exams, and also I am mentoring many students for preparation of the competitive exams like gate and IES and other local group examinations also. So I will be here to guide you and get success in a easier way, not only for the competitive exams, college studies and understanding the core into depth and getting into core placements. I will be helping all of those things. So in this semiconductor or electronic devices circuit series, today we will be getting started more with the semiconductor devices. So let's get into the semiconductor device. Let's conductivity is the parameter that will be generally present for every materials. So in semiconductor, the conductivity will be caused by both P charges and N charges, like N type material and also P type material. Electron and holes both will be contributing for the current or conductivity in the semiconductors. So for the namesake or in the general purpose, we will be using both the N and P in the semiconductors. So NQ mu N, PQ mu P. So we already seen those things. So N is nothing but it will be function of temperature. So N is an parameter, it's a function of temperature. P is also a parameter which is function of temperature. Means the variable or the defined variable values will be depending or changing with respect to temperature. So assuming those things, N is nothing but the free electron concentration. So free electron concentration. Free electron concentration, or we can even state like this: number of electrons in a cubic centimeter in conduction band, because N we are representing, right? If it holds means it will be valence band. So if it is in N means that will be in conduction band. So same for P, that will be free holes. This is an holes concentration, hence in valence band. Holes concentration. Okay, so this you guys know. Both N and P which will be equal to 0 at T is equal to 0 Kelvin, because at T is equal to 0 Kelvin the functional value of both N and P will be 0. So this thing you have to note. So from this instant we know that the semiconductor acts as insulator. Semiconductor acts as insulator. This we already discussed. If you have missed that one, please watch the previous lectures. So even semiconductor will act as an insulator at T is equal to 0 Kelvin. So from this understanding, the last class we have seen about the how the conductivity is affected by temperature. So let's see how here the temperature is affecting the semiconductor's conductivity. Okay, the same thing like 0 Kelvin and 300 Kelvin. So we are going to take three parts. So this part we already know, it will act as an insulator. So below 300 Kelvin and above 0 Kelvin, let's take this region of interest. So what it will happen here now, the same thing last we discussed, right? The oscillation, what will happen? The oscillation of electrons will decreases, oscillation decreases, collision increases. So collision increases. So what we may suspect here is that the same behavior for the temperature may happen here, but that will not happen here. Then because the N and P are what's the dependent parameter of temperature. So here we are taking the T which is less than 300 Kelvin. So comparing to this region, the T is lesser. The T is less than 300 Kelvin. So we are considering the T which is lesser. So means N will also reduce and P will also be reduced. So and assuming both three things, the whole conductivity will be decreased here. But in this case, that is above 300 Kelvin, what will happen? T will increase. Comparing to this one, T is more. So N will be increased, P will be increased. So the total conductivity will increase. So from this simple thing, we came into understanding that the behavior changes for the conductor and semiconductor based on the temperature. So note that. So Eg, which is nothing but energy gap. So this is the energy gap. So silicon is one semiconductor, germanium is another one semiconductor. These two is the majorly used thing. So based on the application we needed, we may choose it. So the energy gap will be 1.21 eV when it is in 0 Kelvin. But if the temperature increases, then the energy gap will be reduced. at what? At 300 Kelvin. So here you see there is a difference, like from 2 1 it's changing to 1 2. Means what happened? And the 300 Kelvin the conductivity is more comparing to when Kelvin at 0 Kelvin. So in germanium the conductivity, the energy gap will be 0.78 eV at 0 Kelvin. But when we consider this in a 300 Kelvin, it will be 0.72 eV at 300 Kelvin. So from this we come into a statement like semiconductor is positive or negative temperature coefficient. If you guys got the answer, please comment in the comment section. So note the important parameter that semiconductor is a semiconductors are negative temperature coefficient of what? Negative temperature coefficient of resistance, because when we increases the temperature the resistance will be decreasing. Then semiconductors are, then another one statement, the semiconductors are positive temperature coefficient of dash. Please fill in the comment section, like fill this gap in comment section. Positive temperature coefficient of dash. So I will giving to this, so just fill this and reply. So in the next class I will be solving one small problem in drift velocity and those things. So before closing this session, let me give you one graphical understanding for the mobility. Like this will give you some good understanding for how the mobility is getting affected based on the temperature. Like every parameter in this world will change for another one parameter. So we are going to study everything in a detail. Okay, so this is mobility mu n. Mu n we may consider that to be constant, but it is based on the temperature, it will vary. Okay, so it's the same. Temperature means we have only two scales, 0 Kelvin, 300 Kelvin, above and below. Like up to 300 Kelvin, the mobility will be increasing, keep on increasing when we increase the temperature. But after that, immediately what happen? The mobility will decreases. The curve will not be this much sharper because it is a differentiable from both ends. So it will trace it and it will cut like this. Okay, so this particular point, it will be the, if we trace the point of differentiation, it will go in the way. So it will be interacting like this. So here the mobility is directly proportional to temperature of 3 by 2. Here the mobility will decrease at the temperature rate of 3 by 2. Okay, so this is how the term. So here we can directly state that mobility is directly proportional to T per m. So m is positive or negative, that is based on the temperature responsibilities. So this is how the mobility will be affected based on the temperature increase or decreases. Then another one term, there is another one for n type and p type, both things there, right? So let's take that into consideration. So this is mobility and this is doping. Doping we haven't started, so just giving an intro to that. So the mobility of n type will be greater than the mobility of p type. So this one we guys already know. So there will be slight difference in the mobility parameter. So the upper curve is mu n and the lower curve is mu p. The value of mobility for n will be greater because this mobility curve depends on another parameter, that is mass. So I will be letting know about the curvature of the energy band and mass dependence for this mobility. So in next lecture we will be studying those. So for now note that these are the two important graphs based on the mobility with the temperature and doping. So this will be very important. So this will give you some more physical understanding of how the things are getting changed based on the temperature and other stuffs. So from this we have the introduction and the mobility, those terms are completed. So from the next class we will be starting with the doping of the semiconductor, like n type, p type, how each will contribute to each other. Let's see both things in a deeper dive. Thanks, like, share and subscribe the channel.